Okay, in this video we're going to look at solving simultaneous equations. If we can just look over here first. Okay, now we're well able to solve this. This is a linear equation with one unknown, and the unknown being x. And the rule is, if we have one equation, we can solve for one unknown. Okay, so we've one unknown here, it's x, we've one equation, so that's no problem, I can solve it. It'll be 2x equals the 15 minus the 7, which would be 2x equals 8, and divide by 2, x equals 4. That's no problem at all. Okay, now this would be a problem if I had x plus 2y equals 4. There's a problem, and the problem lies in that we've one equation, but we've two unknowns. We have an x and we have a y. Now I can't solve that, okay, in that I can't find out what x is and y is, because I have two unknowns and only one equation. However, if I have two unknowns and two equations, well then I can solve it. So that is solvable. Likewise, if I had three unknowns, I would need three equations. Whatever, I would need another equation, so I would need... Okay, so this would be solvable. Okay, if I had three unknowns and three equations. If I had four unknowns, I'd need four equations. Right? For the purposes of junior cert, higher and ordinary, we'll be dealing with two unknowns, two equations. Leaving cert, ordinary level, two unknowns, two equations, and higher level, three unknowns, three equations. Okay, now let's look here to the graph. I'm after drawing the line x plus 2y equals 4. I'm also after drawing the line x minus y equals 4. And I can look and see where they cross. And they cross at the point 2, 1. So there's my answer, 2, 1. Okay, so x equals 2, and y equals 1. So if I do get two equations, so here's one equation, here's the other. I could actually draw them using my knowledge of graphs and find out where they cross. Now, that mightn't be a perfect answer because, you know, based on my drawing, I might be a little bit down here. And I might think, well, actually, is that 2? It might be 1.99 or something like that. And also, it's a lot of effort. So, we do a thing called simultaneous equations, in which we find where we find where they cross, I suppose, if we're looking at graphs. But in terms of just pure algebra, we find out what x is, we find out what y is, using a method called simultaneous equations. Okay, let's just keep that in mind now. We said from the graph that x was 2 and y was 1, just by looking. Okay, let's see now. Let's solve this algebraically using simultaneous equations. Let's see if we get the same answer. Let's see, can we find out what x is and find out what y is. Right, so here we go. X plus 2y equals 4, x minus y equals 1. Okay. So, first of all, a few rules. So, in any equation, I can do a few things to it. First thing I can do is I can multiply across by a scalar. Scalar mean any number. So, for instance, watch this. 6 plus 3 equals 9. That's true. If I decide to multiply across by 2, let's see, can I do that? 12 plus 6 equals 18. Still true. So that means I can multiply across by an equation. As long as I can multiply across the whole way through an equation, as long as I multiply every number in that equation. Let's see if this works now. 6 plus 3 equals 9 again. Let's change it to a minus. Let's change the signs. Minus 6 minus 3 equals minus 9. That's still true. Okay. Let's see if we can do a slightly different. So 6 minus 3 equals 3. Let's change the signs here. Change that to a minus, change that to a plus, change that to a minus. Is that still true? Yes, it is. So, my two rules. I can multiply across by a scalar, and I can change the signs. Okay, so rules. I can multiply by a scalar, so that's any number I want, and I can change the signs. Okay, so I have to change all the signs. Right, so here's my two equations. What I'm looking for is a positive and negative pair here. And what I mean by that is, if I have a 3y on top, I would like to have a minus 3y on the bottom. Or if I had a 2x on top, I'd like to have a minus 2x on the bottom. Or if I had a minus 7x on the top, I'd like to have a 7x on the bottom. So that's what I mean by a positive and negative pair. Okay, and I'm going to have to use these rules, or these tricks, in order to manipulate, so these rules, in order to manipulate one or both of these equations, so I'll have a positive and negative pair. Now, it doesn't matter whether I have my positive and negative pair in the x's, these ones, or in the y's. Okay, so in this one, I think I'm going to look at the x's for my positive and negative pair, right? Because that's probably the easiest one to do. So, how am I going to do that? Well, I'm going to change the signs of the bottom line. So the top line is going to stay the same, x plus 2y equals 4. On the bottom line though, I'm going to change the sign. So I'm going to change that to a minus x. That would be a plus y, and that would be a minus 1. So I'm going to have to change in the signs the whole way across. Once I get that positive and negative pair, there it is now. Okay, so that was my plan all along, to get that positive and negative pair. What I can now do is add vertically. So x and minus x is 0 or nothing. They're gone. And that was my plan all along. 2y and y is 3y. And that equals 4 and minus 1 is 3. So 3y is 3, so y is 1. So I'm after finding y. My next step then is, I choose any of these equations, top or bottom, whichever you want. I'll choose the bottom one. X minus y equals 1. But now, I know what y is. Okay, so as I said, I know what y is, so instead of putting in y, I'll put in 1. So x minus 1 equals 1. So x equals minus 1, take minus 1 from this side, sorry, add minus 1 to this side, add minus 1 to the other, I get 2. X is 2. So x is 2, y is 1, and look over here, it's the exact same as what we had. Okay. Right, so here's a slightly more difficult one. Again, I'm going to use a bit of intuition here, see if I can get my positive and negative pair using my two rules. Two rules are changing the signs the whole way across, or multiplying by a scalar. Okay, I'm going to try and get my positive and negative pair with the x's. Well, if I multiply the top line by 5, right, I'll get 20x plus 15y equals 110. And I'm going to multiply the bottom line by 4. Okay, now why am I doing that? Well, we'll see in a second. So I'll multiply the bottom line by 4 and I'll get 20x minus 16y equals 172. Okay, well I have a pair here. There they are, two 20s, but they're not a positive and negative pair. So I shall change the sign maybe of the bottom line. Okay, top will stay the same. 20x plus 15y equals 110. Bottom line, I'm going to change that to a minus 20x. This will change to a plus 16y. And that will change to a minus 172. Now I have my positive and negative pair. There they are. So I can add vertically. So 20x and minus 20x is 0. They're gone. 15y and 16y is 31y, and that equals 110, and 172 is minus 62. 31y equals 62, divide by 31 on both sides, and I'll get y equals minus 2. I'm after finding my y value. Take one of these equations, whichever I want, or one of these, whichever I want. I will take this one. Okay. Again, it'll work on any of the equations. So 4x plus 3y equals 22. Okay, but I know what y is this time, so instead of putting in y, I put in minus 2. So 4x plus 3, and I know what y is, as I said, it's minus 2, and that equals 22. 4x minus 6 equals 22, and look, here's one equation, one unknown, so I can solve that. So 4x equals, add 6 to both sides, and we'd have 28. Divide by 4, x equals 7. So x is 7 and y is minus 2. Okay, so we're after solving for x and solving for y. If we were to draw this line and this line, again this is now concentrating more on graph theory than algebra, but if we were to draw both lines, do you know where they'd cross? At the point 7 minus 2. Okay, if we were to draw both lines and it was graph theory, and plotting points and plotting lines and stuff. But again, this question can be just a pure algebra question, in that we get two equations and we need to solve for x and y. Okay, thanks.